Hello, so today I will explain you the project that I developed during my internship. It's an ELT data pipeline built on GCP, Google Cloud Platform. It's a simulation of a clothing company. It uses both batch and real-time streaming. And I drew the scheme of this project as you see. First I will explain it in here, then I will go to the corresponding tools and show what I did. Okay, let's get started. So I have a Python code that creates sales and returns data, also the corresponding shipments data. So how I generate the sales data? My code goes to the customers and products table. It fetches all customers and products and stores them in a data frame, and it randomly selects a customer and randomly selects a product and pretend like a customer came and created a sales transaction. Okay, then I sent these data to the BigQuery via PubSub. So what is PubSub? PubSub is a messaging service. It has a structure that contains publisher, subscriber, and the topic. So publisher publishes the message to the topic, and subscriber fetches that message from that topic. In our case, the publisher is the Python code and subscriber is the BigQuery itself. And we have two topics in our project, one for shipments and one for sales and returns. Let's see that in our code, how it works. And let me explain you that. Okay, so we have SQL credentials in here. This is the part where we fetch the tables and put them in data frames. And this is the stock management part. I will explain that too. And this is the generation part, main execution block. Okay, let's run that. It's generating the data. Let's see if it shows up in the cloud. I will open the PubSub tables. Let's see the count of rows. Okay, let's run this query. And we have this amount of rows in this table. Let's run that again and we will see an increase. See it increase, so it works properly for the events table. Let's see the shipments table too. Okay, let's run that again. Okay, so it increased. Perfect. It works properly. Let's stop that and go back to the schema. So then we have restock movements and stock table. And let me show you that in the Python code, how I manage that. So this is the update stock function. So whenever a transaction happens, we will change the stock levels. So if someone buys something, we will decrease the stock levels, and if someone returns something, we will increase the levels. And when our quantity of the stocks goes below 100, a random supply will come and restock that between 300 and 700. Okay, so let's go back to the schema again. And how I send these data to the BigQuery, I use a tool called DataStream. So what is DataStream? DataStream is a tool that uses a method called CDC, Change Data Capture. So what Change Data Capture does is it basically keeps our destination in sync with our source. So in our case, it keeps BigQuery in sync with the MySQL database. So our stock table is always changing, and if I want to see that change in the Power BI in our dashboard, I need to send the data in real time, and DataStream is a perfect solution for this. And let's see if it works. I will run that again. So right now we are generating data, so the stock levels are always changing. We will go to the stock table in our cloud. So as you see, we have a column called last updated. So we will sort the table by that. Let's order by that. Okay, let's run that query. We have an output, and when we run that query again, we should see different output because the transactions are ongoing, as you see. And when we run, we will see different output. Okay, so it changed. I will run it again. So it changed it again. So we are managing the stock levels and sending these data to the cloud. Okay, perfect. Let's stop that and go back to the schema once again. So we have branches and suppliers table. These are tables that doesn't change often and doesn't need automation. So I sent them via BigQuery data transfer service. So what it does is it's basically a no-code transfer service, and it's an easy solution for these kind of tables. So I used that, and we have products and customers table. I use Dataflow for them. Dataflow is one of the most used GCP service, I can say that. I will show how I run them in Airflow part, and let's go to the transformation part. So for the transformations, I used a tool called Dataform, and I used the Medallion architecture as you see in below. So let's see the Dataform. Okay, I'm keeping my data organized in folders. And let me show you some of SQLX files. So if you remember, I stored all returns and sales in landing zone in the same table. Right now I'm separating them with this where clause because only the return values have return sale ID, and if we go to this table too, we will see the reverse where clause. Okay, so we have a bunch of tables, bunch of SQLX files. Let me show you the compiled graph of them. Okay, so this is the compiled graph, and I will go back to the schema. Okay, so this is how I do the transformations. You can find them in my GitHub to see all of the SQLX files. Then I will go to the automation part. So I use Airflow for the automations, and I scheduled the data flow and the data form because others don't need scheduling. And I created a CI/CD because uploading the Airflow code by hand is so manual. So I uploaded my Airflow codes to my repo to GitHub. Then I created a GitHub Actions. So what this action does is whenever I push something to the GitHub, it will be triggered and it will send these files to the cloud storage, to Airflow's cloud storage, and Airflow will automatically detect this change, and we will see that change in the Airflow UI user interface. Okay, let's do that. So I will commit this. Okay, so I pushed it, and let's see that in our repo. The GitHub action is triggered. Okay, let's wait for that. It will take about 90 seconds. Okay, so it succeed, and let's see that in storage bucket. I will open the composer. Let's open DAX folder and also the web server. So look at the clock, we did the push a couple minutes ago, and it happened 1 minute ago, as you see. Okay. So this is our DAG. So now we pushed it, and I will trigger that. Now let me show you that. And you see it's pushed. So let's trigger that. While it's running, let me explain you this code. It's an incremental load. So we have a watermarks table which stores the table name and the last process time. So in this code we will fetch the customers which are created after this last process timestamp. So we will fetch these customers, and after we successfully fetch them, we will change the last process timestamp, and that way we create an incremental load. Let me show you the table, the customers table, because we are going to add some columns, and you should see the first state of that table to see it successfully updated the rows and add the new rows. Okay, so this is our table. Okay, so we have 4,700 rows, and once we finish that, it should be increased, but it will not be duplicated. That's the point of incremental load. Okay, so it's successfully done, as you see. We will see that in here. So the last process timestamp column is right now this state. Okay, so this task succeed. Let's see the change in our table. I will run this and we will see an increase.
Ben seni sevmeyi
but we did not duplicate the values. So let's try that. Select distinct. Okay, so all values are distinct. Now let's go back to the DAG. Okay, so we updated the watermark table too, and let's see that. I will refresh this and it will be set to the current dates 4 a.m. Okay, so it changed. Perfect. So let's go back to the schema. This is how I managed this part, and then I created some dashboards from the gold layer table and marked layer tables we use. Let me show you that too. So I have the PDF of these dashboards because I cannot run Power BI in Linux. Let me show you the dashboards. So these are our dashboards, and that's all.
Ben seni sevmedim ki sana gönül